Welcome to Python Intermediate 6, Modulating Our Code. Every video will have all slideshows and code available in the description. Modulating our code in Python is the process of splitting up our program into multiple files. Python keeps this as easy as possible while also allowing for complex packages to be made. Splitting up our code can make for more manageable code, as well as the ability to make each file have a specific purpose. Making packages is a great way to compile tools for other developers, because they can just import the stuff they need. Designing a program with modules in mind is a strong skill to learn when programming. Though this is something you usually figure out how to do on yourself, some tips would be to keep classes that will or could be used in multiple files as their own separate file, and making sure every file has a specific purpose. To use the code from another file, we have two possible ways. One is to just import the module, and then we have to declare the module before using each class or function, or to use the from keyword and import a class or function for direct use. So let's have a look at splitting up our code into two files. We'll have a vector2d module and a mod module. The mod file will have our main function and will import the vector2d module for use. We'll also look at the two ways of importing. So let's create a vector2d.py. If you still have the code from our class tutorial, you can just import that. And we'll also create a mod.py file. So I'll create my vector2d.py. And I'm just going to make a simple vector2d class. So class vector2d. And it will have an initialization. Oops, I need to def that. Def init. So it's going to take itself, an x and a y. And self.x equals x. And self.y equals y. And that's the vector2d base skeleton done. So I'll save that. Now I'm going to create one more file, which is going to be the mod.py file. And in here we're going to import our vector2d module. So we're going to go import vector2d, and now that that's imported, we can start writing our main function. So we'll go def main, and inside our main we're going to create two vectors. So we'll create vec1, which is going to be equal to vector2d, so the module name, dot, and then the class, so vector2d. And the class has capital V and capital D. And we'll set the x to 5 and the y to 6. And we'll create another vector, so vec2 equals vector2d module with the vector2d class. Oh, where have I bug it up somewhere? Oh, in the first line I missed a C. Okay, and we'll just set this to 1, 1. Now we'll print them out to see that it's working. So print vec1.x, print vec2.y, print print vec1.y, sorry, vec2.x, and print vec2.y. Now we'll write our if, so if underscore name underscore equal to main, then we want to run main. Okay, so now we can save this and we can check out how our import worked. So we only have to run one file, so we run our mod file, the one that contains our main. So python mod.py, and we get the output of 5, 6, and 1, 1. So our first vector was 5, 6, and our second vector was 1, 1. So that all worked correctly. Now we'll look at the other way of importing. So rather than using the import command or keyword, we can use the from keyword. So from vector2d, the module, we want to import the class, so vector2d, and that will import a class for direct use. So what we can do is we can remove the module reference at the start and just call the class name. And we don't have to worry about specifying what module that class came from. And now if we save this and we run it, we should get the same output. Yep, so our vector worked correctly. We took it from our other file and used it in our main file. Okay. Lastly, we have packages. Packages are more complex structured, used for compiling large amounts of modules. These could be things like physics engines, networking tools, or even graphical packages that allow you to make windows for the user to interact with. Packages span multiple folders. You have the base package, which is then split into sub-packages, if needed. Python also uses special file names to do certain tasks in a package. For an example of a package, there will be a zip file in the slides folder, which will have codeless files, but will have a comment in each file detailing how to access that module, or what the file does. If you're interested in packages, I suggest looking in the init.py file. This concludes our look at modulating, and also the intermediate series. Code will be available in the code.txt and in the slides folder, as well as a challenge task. Don't fear if you don't remember all of this, you can easily come back and rewatch this video to consolidate all the information. If you have any questions, feel free to leave them in the comments. Thanks for watching.